Okay, the first problem is solved. Now we have an image, and its RGB or CMYK numbers are no longer ambiguous. It has color meaning and a color appearance that we want preserved. How does color management do this? Through conversion of the RGB or CMYK numbers. Let's take a step back for a moment. If you send the same CMYK numbers to a color laser printer and to a press and get back two different color appearances, what do you do, typically, to make them the same? You take the image into something like Photoshop, and you use curves, maybe hue saturation, to change the numbers in the file. You make a print, you change the numbers again, you make another print. Maybe you do this several times to get the color appearance you want, but you've changed the numbers. What we want color management to do is to come up with the correct RGB or CMYK numbers in the first place, so we don't have to preserve the color appearance we want. To do this, we need a second profile, a destination profile. The source profile describes the color space our image or illustration is currently in and brings meaning to its RGB or CMYK values by relating them to XYZ or lab. The destination profile contains XYZ or lab values and references them with the RGB or CMYK values necessary to create those XYZ or lab colors on that profile's display or output device. Follow along with this. If we send the same CMYK values in a file such as a TIFF to two different printers, we will get back prints that have two different color appearances. However, if we send two sets of CMYK values, two separate files, custom ones that take the output device's characteristics into account, we will get back prints that have two very similar, although likely not perfectly identical, color appearances. This is a big deal. For example, I want to perform an RGB to RGB conversion from Scanner RGB to Adobe RGB 1998. This is the scanner profile assigned to this document. It's the source profile, which assigns color meaning to the RGB values from the scanner, which are contained in this document you see here. I want to convert this image to Adobe RGB 1998 for image editing purposes. I just don't want to edit in Scanner RGB. I want to convert because I want to preserve this color appearance. It's not the RGB numbers that are important, but rather the color appearance. I'll put a sample point here and here to keep track of the RGB values. You can see the corresponding RGB values in the info palette over here. So now I'll go to Convert to Profile. And for destination space, I'll select Adobe RGB 1998. Unfortunately, the Convert to Profile dialog doesn't give us split numbers before and after, like the Assign Profile dialog. But I can toggle the Preview checkbox and show before and after conversion, the RGB numbers change considerably. Before conversion and after conversion. Yet the color appearance on screen stays the same. We can confirm this by changing to lab color in the info palette. Lab values before conversion and after conversion, indicating color appearance has been preserved. They're not changing because the job of Convert to Profile is to change numbers to preserve color appearance. Notice here is my source profile. And over here is my source profile. If I select OK, I'll be converting to the destination space, Adobe RGB 1998. The numbers, the RGB numbers in the file will change. Notice that instantly the source profile changes accordingly. The destination profile has become the source profile, which brings color meaning to the new RGB values in the document. Color management really does only two things. It brings color meaning to eliminate the ambiguity of RGB and CMYK numbers, which are just control signals for our devices. And it performs conversions necessary to preserve color appearance from device to device. At the center of all of it is an unambiguous color space, either XYZ or lab. You might be wondering, what does all this work? The profiles themselves aren't programs. How do the profiles get used? We need some kind of brain or engine to do some work using our profiles. You're in luck because color engines are the next movie.